Here are the solutions for the first signature test we had. The first thing you were supposed to do in this problem number 1 was to label on the diagram the congruent angles, sides, right angles. And what I have here on mine is the minimum that you needed to have. Because this is a rectangle, you not just identify that the angles were congruent, but you needed to mark that they were specifically right angles. So we need right angles in the corners of the rectangle. Opposite sides are congruent with one another, and the opposite sides are parallel. Now most of you knew that, but because this got so crowded with tick marks, I didn't put it on my answer key, but you should know that too. On the right trapezoid, we have a right angle here. You needed to have that this was also a right angle here on the other side of the bases, and that the bases, which are running vertically here, are parallel with each other. Isosceles triangle tells us that it has two sides of the same, and that's the minimum. But we should get used to the fact that an isosceles triangle that has two sides of the same, also the angles opposite them are congruent. So we should get used to marking that, but I didn't make it mandatory on your SIG test. With the rhombus has all four sides are congruent. That's the most important one. We've got a lot more things you can mark with the rhombus, though. We've got each pair of opposite angles are congruent, so top and bottom and the left and right. They're not congruent with each other, so we've got to use some sort of different tick mark there. And the opposite sides are also parallel, so if we inserted parallel marks with each other, and you can see how crowded that got. So yours may have been that crowded, but the bare minimum was to know that all four sides of a rhombus are the same. Okay. Has at least one right angle, so you can see these two rectangle and right trapezoid are the two that fit that category, so they would fall inside this circle. If we head over here to rotational symmetry, for most of these, and not all of them, but for most, and this one, if you rotate it at 180 degrees, do you end up with the exact same looking picture? So for example, this isosceles triangle, which is sitting right there on this side, which we'll call the base, if I were to spin my paper 180 degrees, it's still the same triangle, but you can clearly see it's upside down. So that doesn't have rotational symmetry. As opposed to, say, the rectangle, where if we were to spin it 180 degrees, you end up with the exact same rectangle. So the rectangle and the rhombus have rotational symmetry on this problem. So that's why they're inside this circle. So the rectangle shared both. That's why it's in this shared section. And the isosceles triangle had neither one of these, so it sits outside your Venn diagram. Number 2 was solving some equations. These are just some linear equations, so make sure you distribute correctly. That -2 would get distributed to the x and the -3. Very common to have an error right there, so hopefully you did that correct. Here you need to distribute the 3 to the x and the 1. That's what's happening here. Now I did a couple steps in my head at this point. For example, I took this -2x and I moved it over to the right side by adding 2x. So you don't see my work there. There's adding 2x, which is why I have 5x now. I combine like terms in my head. This is just +1, and I combine these guys since they're on the same side of the equal sign. That's just 10. And I took this +1 and I moved it over to the left side by subtracting 1 from this side, which is why this 10 turned into that 9 right there. Last step would be to divide, and we're looking at 9/5. This is just a proportion problem, so you should be cross-multiplying or butterflying or whatever you were taught the term was. So these guys need to be multiplied together. These terms need to be multiplied together, and you'll set those equal to each other after you do that, and be sure to distribute and solve. Problem number 3. You had to complete the generic rectangle, and then, the most important part, write the area as a product and as a sum. So on the first diagram here, you just simply had to take the lengths and the widths and multiply them together to get the areas of each of these individual rectangles in the generic rectangle. Once those were filled out, then the area as a product means to write the length times the width. So these two things that I'm circling here, you'll see are right here. I always just write the shorter of the two first, so technically I did the width times the length. When you go to write the area as a sum, that's to add up everything on the inside here, and you're going to notice from time to time like terms. For example, these guys here that I'm circling, this -9x² and -2x², they add to negative 11x squared, and that's what I've done here to combine those. Also, these diagonals are like terms, and they got added to be 11x. This one was a little trickier because you kind of had to work backwards and figure out what went along the outside. But just be sure when you're done to write the area as a product, which is this first part, length times width, and as a sum, which is the area of everything on the inside being added up. Okay, if you need more time with these, also press pause and take a look at it. I don't want to be going too fast, but I'm limited by time here to a 10-minute video. On problem number 4 here, you had to find measure of angle CAT. So from C to A to T. This big angle here was the ultimate task. The first thing you should recognize is this angle here, this 3x plus 15, is opposite this 90-degree box, which means it's also 90 degrees since it lies on a straight line. So I set 3x plus 15 equal to 90, and that allowed me to solve for x. Now don't box that or circle that on your test. I'm just showing you because you need that to find the big angle CAT. So once you know what x is 25, if you simply put 25 in for that x and 25 in for that x, you'll get these two smaller angles, and together they make the big angle CAT that you're trying to find, and that's where we get 143. Over here, I used the fact that this angle here, this big giant angle, is 153 degrees, which means that this little sliver inside the triangle has to be 27. So if you set 27 equal to that corner angle, x minus 10, it will allow you to solve for x, giving you 37. And now that you know x is 37, you can use that fact to find this big angle up here. If you plug 37 into that x and you plug 37 into that x, you get the fact that those two angles are 115 and 27. And we need to know that the sum of the angles of a triangle add to 180. And if you know what two of them are, the third one, which is the one you're trying to find, can be found fairly quickly by doing 180 minus those two numbers. And that's where 38 came from. On 5, this one was a little tricky because it had some decoys here. You had to find x and then give reasons for your answer. And you'll notice this line here going across and this line here are not parallel. So we can't go from this intersection to this intersection and have any relationships like alternate interior, corresponding, etc. So it's a big decoy. This is a big giant decoy. Watch out for that. Since these are your parallel lines, this is the transversal going across here. We're going to use this fact that D is 55 and try to work our way back here. Now there are several ways. So if you're looking at my answer here, you might discover that I did it a different way than you might have, and that's totally fine. What I decided to do was go from D to B because those are called corresponding angles. So I said B is 55 because it corresponds with D. Once I have B is 55, I know that X is 55 because those are called vertical angles. And now we've located X and we're done. So it just took 2 steps that way, but most of you could have done it in 2 steps other ways. On the one down here, a little bit trickier. D was given to you to be 70 degrees. So I said if D is 70, then A is also 70 because those are called vertical angles. And I did this. A and B together are this large angle here. Hopefully you can see that. And those add to be 113 degrees. Well, that large angle there is the same as this angle there because they're corresponding. If here's your parallel lines, you've got a transversal. This guy might mess you up, but they're in the top left corner of the intersection. Therefore, they are called corresponding. So that's why I have it's corresponding to angle A and B. Last one, number 6 here. We had eats 10%, so you had to realize that that was losing 10%. And if something is losing a percent, we start with 100%, and in this case, we subtract 10% to find our multiplier. If we were making money or this was an increase, we would have added it to 100%. So we get 90%. So I have 90% of my couches left each day, but we have to convert that to a multiplier. As a decimal, we move the decimal 2 places. So 0.9 became our multiplier inside the parentheses. Our initial value was out here. That's how much the couch weighed, 110 pounds. And this is your time units. This says in 7 days. So we put a 7 there because this is in terms of days or daily. And 5 days ago, we would just change the time to -5.